Hello, calculus fans. Remember that we looked at the heat index, that's the perceived temperature, as a function of the actual temperature and the relative humidity. And we had a table of values from the National Weather Service. I'll give you that table in a minute. And what I'd like to do now is find a linear approximation for the heat index when T is near 96 degrees and the humidity is near 70%. And let's use that linear approximation to estimate the heat index when the temperature is 97 degrees Fahrenheit and the relative humidity is 72%. And just to remind you, this is what the heat index table looked like. It gives you a table that tells you what the perceived temperature is as a function of temperature, actual temperature, and relative humidity. Now the table tells us that F of 9670 is 125. That's the heat index when the temperature is 96 and the humidity is 70. Now remember that we estimated a few things from the table. In particular, we estimated that the partial derivative with respect to T evaluated at 9670 is about 3.75, and the partial derivative with respect to H at the same point is about 0.9. So we can write down a linear approximation. So once we have all this information, we can write down a linear approximation which looks like this. So we start with the actual value of F of 9670, and then we have two terms, F sub T at 9670 times T minus 96 plus F sub H 9670 times H minus 70. Plug in all the numbers and we get an expression that looks like this. So if we plug in 9772, then we get about 130.55. That's telling us that the heat index is approximately that at the temperature and humidity that we're interested in. So we can say that when the temperature is 97 degrees Fahrenheit and the relative humidity is 72%, the heat index is approximately 130.55. Okay, that's all for now.